cosine graphs. Well, cosine graphs are very, very similar to sine graphs. If anything, they're just a sine graph that's been shoved over a bit. But the same principles apply when sketching the graphs. Now, what we're going to do first, as says here, using the exact values, fill in the tables on the right. So I know that it says here we haven't bothered doing radians. We're just going to go straight with degrees. Well, cos of 0 is 1. How do I know that? That is because, of course, using my unit circle, I can fill that in. So it goes from 1, 90 degrees is 0, 180 is negative 1, 270 is 0, and 360 is back to 1 again. So cos 60 degrees, well, if you're very, very clever, you might notice that cos 60 is the opposite of sine 30. So that is a half. Now, in the second quadrant, cos is negative, because we use our little symbols there, so that's going to be negative a half. In the third quadrant, it is still negative, and in the fourth quadrant, it is positive. So when we're sketching the graph, unlike the sine graph, we actually start at 1. We ignore 30, we go to 60, go to 90s there, and then 120 is negative a half, ignore 150, go to 180 is negative 1, and then ignore 210, 240 is negative a half, and then we'll put the 0 there, 300 is a half, and so what we get is we get a graph that looks something like this. Now you might be thinking that's a completely different shape, but actually, since it actually keeps going in the negative sides, it'll keep going this way and it'll keep going that way. It is actually very similar, if not identical, to the sine graph. It's just moved over. In this case, it's sort of moved to the left by, half of that hill, if you like. The terminology is exactly the same. So this is still the amplitude here. That distance is still the amplitude. This is still the period, that whole pattern there, that one complete cycle is still the period, and it's still calculated in the same way as the sine graphs. So it's 2 pi over n, where n is whatever's on the inside there, and the amplitude, which is the distance from the vertical midpoint to the maximum there, and we put that as a number at the front. Sketching cos graphs with no translations is similar to sketching sine graphs with no translations. The only thing is that the odd quarter is an x-intercept, not a turning point. So if, and of course, if the number at the front of the cos graph is less than 0, then we flip it upside down. Sketch one complete cycle of each of the following and state the period and amplitude. So this is y equals cos 2x. So the amplitude is 3, the period is equal to 2 pi over 2, which is equal to pi. Similarly to the other ones, what I'm going to do is I'm going to break that x-axis into approximate quarters. So, because we have to just draw one cycle, pi, pi on 2, pi on 4, 3 pi on 4. And the amplitude is 3, 3, negative 3. So it starts up here, then goes down, goes here, goes there, and goes back up here. So here is our cos graph. 4/5 cos x on 2. So just so you're aware, this is also the same as saying 4/5 cos 1/2 x. That's the exact same thing there. So the amplitude is 4/5. The period will be 2 pi divided by 1/2, which is equal to 4 pi, because 2 pi divided by 1/2 is the same as saying 2 pi times by 2. Split up into approximate quarters, 4 pi there, halfway is 2 pi, that's a pi, and that's a 3 pi. We've got a amplitude of 4/5, this will be negative 4/5. And again, there's been no reflections or translations, so it's the exact same pattern. Y equals negative 2 cos 5x. So we've got an amplitude here, equals 2. A period of 2 pi divided by 5, which is, ooh, this is awful, this one. This is a 2, that is the period. It's going to be 2 pi over 5. Ooh. And it's been reflected. Again, we're going to keep our head. We've got to be calm. We'll get through this one as much as gross as this might look like. 3. So there's my quarters. 2/5 over pi. Halfway would be pi over 5. Half of that would be pi over 10. And this would be 3 pi over 10 over here. The amplitude is 2, yep. So it's 2 and negative 2. But of course it's upside down. So it starts here, then goes here. An examiner will appreciate like a thick continuous curve. Please don't draw a hairy graph. If you're not familiar with the term hairy graph, it's when people try to treat graphs as if they're works of art and they're sketching, and you'll get people drawing graphs like that, hairy graphs. No, don't do any of that. Just one continuous curve. As long as it looks like a cos graph, then it's fine. If you've drawn some sort of weird upside down parabola, that's wrong. Sketch the following. And this one's a bit of a doozy, because have a look at that domain. It's going from -4 to 1, and we've got -2 cos pi a. So let's go and have a look at the amplitude and period and so forth. So the amplitude is 2. It's been reflected in the x-axis, so it's a bit awful. The period is 2 pi over pi, so it's equal to 2. So what I'm going to do is I'm going to label the graph accordingly. 1, -1, -2, -3, and -4. And 1, 2, I'll make that 2, make that -2. And what we're going to do is we're going to go and sketch it as we would normally would. So you'll probably be aware that, of course, that we would start, because it's upside down, we'd start from this 0, -2 point and move our way up. We'll be doing that, but just going in reverse. Now, before I make this mistake, I better make sure I break this up into quarters. So that's -1/2, that's -3/4. That is -5/4, and that is -7/4, and that's a half. So what I'm going to do is the exact same pattern that I would do before. I'm just going to use my pink here, like so. And there is our graph. Now, it's always worthwhile to use the calculator to confirm your answer. What you don't know is that I actually edited this video, and I actually had stuffed this graph up royally. And it wasn't until I checked it on the calculator to realize what my mistake was. So now is a great opportunity to do so. So I'm going to bring up my CAS calculator. So here's my graphing tab. You'll notice there I've put in the equation what it is, -2 cos pi x, but you'll notice there it's got a little vertical line. You can access that vertical line by going to Math 3, and there's the vertical line right there. That's the restriction function, and what that does is it restricts your graph so it only appears to the domain that you want, and we want it to go from -4 to 1. Why is this important? So if I just get rid of it for a second and I sketch this graph, as you can see, it just goes on forever. So whilst it can be a little bit useful, we just want to see what our one looks like. So there's our restriction. We'll put that in there, and there we go. So we've got our graph as it should look like there.